Imagine standing at the edge of a vast uncharted ocean, where the horizon stretches into infinity, and the waves whisper secrets of worlds unseen. That's where we find ourselves today, peering into the outer reaches of our solar system, where a newly discovered dwarf planet, 2017 OF 201, has ignited a cosmic mystery that could unravel one of astronomy's greatest puzzles. This isn't just another speck of light in the night sky, it's a celestial breadcrumb leading us toward answers about the elusive Planet 9, a hypothetical giant that may be hiding in the shadows. Buckle up, because this journey through the Kuiper Belt and beyond is going to be a wild ride, one that will keep you hooked until the very last word. And trust me, you'll want to stick around. There's a call to action at the end that could make you part of this cosmic quest. Picture this. It's a chilly night in Chile, and the Blanco telescope's dark energy camera is scanning the heavens, capturing faint glimmers of light from objects so distant they barely register. Between 2014 and 2018, a team led by Dr. Seihao Shang at the Institute for Advanced Study in Princeton sifts through years of data, chasing a hunch. They spot a faint, slow-moving dot, barely shifting against the starry backdrop, but just enough to stand out. That dot, it's 2017 OF 201, a dwarf planet that's just gate-crashed our solar system's VIP list. Discovered officially in 2017, this isn't your average space rock. At roughly 700 kilometers in diameter, it's a heavyweight in the Kuiper Belt, ranking among the largest Trans-Neptunian objects, TNOs, second only to giants like Pluto, Eris, and Makemake. Its spherical shape, sculpted by its own gravity, earns it the prestigious title of a dwarf planet, a cosmic cousin to Pluto, with a story that's anything but ordinary. What makes 2017 OF 201 so extraordinary isn't just its size, it's the way it dances through space. Its orbit is a cosmic roller coaster stretching from a close approach of 44.5 astronomical units, AU, just beyond Pluto's orbit, to a jaw-dropping 1600 astronomical units, a distance 1600 times farther than Earth is from the Sun. To put that in perspective, 1 AU is about 93 million miles, the distance from Earth to the Sun. At its farthest, 2017 OF 201 is so distant it's practically waving from another postal code in the galaxy. And here's the kicker, it takes 25,000 years to complete one orbit around the Sun. That's longer than all of recorded human history. When our ancestors were painting caves, this dwarf planet was just starting its cosmic commute. We only caught a glimpse of it because, by pure chance, it was near its closest approach to the Sun in November 1930, the same year Pluto was discovered. Talk about cosmic timing. To understand why 2017 OF 201 is such a big deal, we need to zoom out and explore the wild, untamed frontier it calls home, the Kuiper Belt. Beyond Neptune, the 8th planet from the Sun, lies a vast, donut-shaped region of space stretching from about 30 to 50 astronomical units. This is the Kuiper Belt, a cosmic attic filled with icy bodies, dwarf planets, and the ghosts of our solar system's formation. Until the 1990s, the Kuiper Belt was just a theory, a hypothesis born from the math of orbiting comets. Then, in 1992, astronomers confirmed its existence, spotting the first Kuiper Belt object KBO beyond Pluto. Since then, we've cataloged thousands of these icy wanderers, but we've only scratched the surface of this frozen wilderness. Go even farther, and you hit the Oort cloud, a spherical shell of comets that might mark the true edge of our solar system, thousands of astronomical units away. The Oort cloud is so distant we've never directly observed it, but its gravitational whispers suggest it's the birthplace of long-period comets that occasionally streak across our skies. The Kuiper Belt, though, is closer and more tangible, yet it's still a realm of mystery. Its inhabitants, known as Trans-Neptunian objects, range from tiny icy chunks to dwarf planets like 2017 OF 201, but something strange is happening out there. Astronomers have noticed that certain TNOs aren't scattered randomly. They cluster in specific regions, their orbits aligned in ways that defy chance. It's as if an invisible shepherd is herding them into formation, and that's where the idea of Planet 9 comes in. For years, astronomers have speculated about a massive, unseen planet lurking beyond the Kuiper Belt, a world up to 6 times the mass of Earth, possibly as large as Neptune, shaping the orbits of distant objects like a cosmic puppeteer. This hypothetical giant, dubbed Planet 9, could explain why some TNOs follow peculiar, elongated paths, their orbits tilted and clustered at angles around 60 degrees. The theory gained traction in 2016 when astronomers Mike Brown and Konstantin Batygin at Caltech published published a groundbreaking paper, arguing that the gravitational pull of a distant planet was the only way to explain these orbital oddities. Their simulations suggested Planet 9 could be orbiting at 300 to 450 astronomical units, with a semi-major axis of 380 astronomical units and an orbit tilted 16 degrees off the solar system's main plane. If it exists, it's likely at its farthest point now, moving sluggishly across the sky, hidden among countless stars. But Planet 9 is a controversial character. Some astronomers are convinced the evidence is compelling. After all, the clustering of TNO orbits is hard to dismiss as random. Others argue it's circumstantial, a pattern that could have other explanations, like the collective gravity of smaller objects or even observational bias. Enter 2017 OF 201, the dwarf planet that's thrown a wrench into the Planet 9 hypothesis. Its orbit doesn't fit the mold. Unlike the clustered TNOs, 2017 OF 201's perihelion, the point where it's closest to the sun, is angled at 306 degrees, wildly off from the 60-degree alignment of its neighbors. This rogue orbit raises a big question. If Planet 9 is out there, why isn't 2017 OF 201 playing by its rules? Dr. Sihao Shang's team didn't just discover 2017 OF 201, they ran simulations to test its place in the Planet 9 puzzle. What they found was startling. In models where Planet 9 exists, its massive gravity would destabilize 2017 OF 201's orbit within just 100,000 years. A blink in cosmic time. The dwarf planet would get too close to Neptune, slingshotting out of the solar system like a cosmic pinball. But in simulations without Planet 9, 2017 OF 201's orbit remained stable for over 1 billion years, calmly tracing its eccentric path. This suggests that the existence of 2017 OF 201 might actually argue against Planet 9. It's not definitive proof. Science rarely deals in absolutes, but it's a serious blow to the hypothesis. If Planet 9 is out there, it's hiding in a very specific corner of the sky, and astronomers are narrowing down the search with unprecedented precision. The discovery process itself is a testament to human ingenuity. After spotting that faint dot in the dark energy camera's images, Shang's team turned to the Canada-France Hawaii telescope for confirmation. Additional images locked in 2017 of 201's movement, proving it was no fluke. Today, it sits at 90.5 astronomical units from Earth, one of the most distant objects ever observed with visible light. Its brightness and size suggest it's not just another icy rock, it's a dwarf planet with a story to tell, and that story might rewrite our understanding of the solar system. The hunt for Planet 9 is like a detective story spanning the cosmos. Mike Brown and Konstantin Batygin have become the Sherlock and Watson of this mystery, armed with supercomputers and an obsession with the unknown. Their latest simulations, updated as of 2025, have refined the search for Planet 9 to a narrow band of the sky. They've modeled countless scenarios, tweaking variables like mass, orbit, and gravitational influence. One possibility places Planet 9 at a semi-major axis of 380 astronomical units, with a mass 6 times that of Earth. Another suggests a smaller world, perhaps 2.2 Earth masses, sneaking as close as 85 astronomical units. Its orbit, tilted at 16 degrees, makes it a cosmic wildcard, refusing to conform to the solar system's orderly plane. But finding Planet 9 is no easy task. At its farthest, it could be so dim it blends into the starry background, moving so slowly it's nearly impossible to spot. Yet there's a tantalizing possibility. We might have already captured it in telescope images. Archived sky surveys, like those from the Vera C. Rubin Observatory, could hold the key. The challenge is sifting through billions of pixels to find a faint moving object. That's where technology, and people like you, come in. Now, let's pause for a moment and consider the sheer scale of this endeavor. The search for 2017 OF 201 and the broader quest for Planet 9 aren't just about telescopes and equations. They're about collaboration on a galactic scale. As of August 22, 2025, observatories across the globe, from Chile's Cerro Tololo to Hawaii's Mauna Kea, are working in tandem, sharing data through international networks like the International Astronomical Union. These efforts are bolstered by cutting-edge AI algorithms that can analyze vast data sets, picking out patterns that human eyes might miss. But it's not just professionals in the game. The rise of citizen science has turned this cosmic hunt into a global movement with thousands of volunteers, ordinary people with a passion for the stars, contributing to discoveries from their laptops. Platforms like Zooniverse have democratized astronomy, making it possible for anyone to help spot a distant world. Imagine the thrill of being the one to flag a faint moving speck that turns out to be a game changer. This isn't just science, it's a symphony of human curiosity, technology, and the relentless drive to know what lies beyond. The discovery of 2017 OF 201 is more than a single moment. It's a chapter in the unfolding story of our solar system. This dwarf planet, with its wild 25,000-year orbit, challenges us to rethink what we know about the outer reaches of our cosmic neighborhood. Its existence hints at a Kuiper belt teeming with undiscovered worlds, each with its own tale to tell. Scientists estimate there could be hundreds, if not thousands, of objects as large as or larger than 2017 OF 201 lurking just beyond our current reach. As telescope technology advances with projects like the Vera C. Rubin Observatory's Legacy Survey of Space and Time, LSST, now in full swing as of 2025, we're on the cusp of a new era of discovery. The LSST, with its unmatched ability to map the sky in unprecedented detail, could uncover dozens of new TNOs, each adding a piece to the Planet 9 puzzle, or perhaps proving it's a mirage. The legacy of 2017 OF 201 lies not just in what it is, but in what it represents. A reminder that our solar system is a living, dynamic place, full of surprises waiting to be found. There's something deeply human about this quest. Staring up at the night sky, we've always wondered what's out there. From ancient stargazers mapping constellations to modern astronomers chasing Planet 9, the discovery of 2017 OF 201 taps into that primal curiosity, that urge to explore the unknown. It's a reminder that even in 2025, with all our technology and knowledge, the universe still holds secrets that humble us. There's an emotional weight to this journey, a mix of awe, frustration, and hope. Every new object like 2017 OF 201 is a step closer to understanding our place in the cosmos, but it also reminds us how vast and mysterious the universe remains. It's a call to keep looking, to keep questioning, to keep dreaming. Whether Planet 9 exists or not, the search itself is a testament to our relentless drive to push boundaries, to seek answers even when they're hidden in the farthest reaches of space. Let's dive into the technological marvels powering this cosmic detective work. The discovery of 2017 OF 201 wouldn't have been possible without the dark energy camera at the Blanco telescope in Chile, a beast of an instrument capable of capturing light from objects billions of miles away. As of 2025, this camera, paired with advanced image processing algorithms, has revolutionized how we explore the Kuiper belt. But it's not alone. The Vera C. Rubin Observatory, now fully operational, is a game changer, scanning the sky with a 3.2 gigapixel camera that generates terabytes of data nightly. This fire hose of information is analyzed by AI systems trained to detect the subtle motions of distant objects, like 2017 OF 201's sluggish crawl across the sky. These tools are our eyes in the cosmos, extending our reach far beyond what was imaginable even a decade ago. Yet they also highlight a humbling truth. For every answer we find, the universe poses a dozen new questions, each beckoning us to push our technology and our imaginations further. The story of 2017 OF 201 and the search for Planet 9 isn't just a scientific saga, it's a cultural phenomenon sparking wonder across generations. As of August 22, 2025, social media platforms like X are buzzing with discussions about the dwarf planet, with hashtags like #Planet9 and #Kuiper Belt trending among space enthusiasts. Educational programs, from virtual planetarium shows to school curricula, are incorporating this discovery to inspire young minds, showing them that science is a living, breathing adventure. Museums and science centers worldwide are hosting exhibits on the outer solar system, complete with interactive simulations of 2017 OF 201's orbit. This isn't just about finding a new planet, it's about igniting a passion for discovery in a world often distracted by the mundane. The idea that a hidden world might be out there, waiting to be found, resonates with our collective desire to explore, to dream big, and to connect with something larger than ourselves. Looking forward, the discovery of 2017 OF201 is a springboard for the next phase of solar system exploration. As of 2025, plans are underway for next-generation telescopes, like the proposed Large Ultraviolet Optical Infrared Surveyor, LUVOIR, which could peer even deeper into the Kuiper Belt and beyond. Meanwhile, space missions targeting the outer solar system, such as potential flybys of distant TNOs inspired by the New Horizons mission to Pluto, are gaining traction. These projects, combined with ongoing citizen science efforts, promise to uncover more objects like 2017 OF201, each a puzzle piece in the grand cosmic mosaic. Whether they confirm or debunk Planet 9, these discoveries will reshape our understanding of our solar system's architecture. The future is bright, or rather faintly glowing with the light of distant worlds, inviting us to keep exploring, to keep questioning, and to keep chasing the mysteries that lie just beyond our grasp. Now, let's take a step back and marvel at the intricate dance of gravity that governs objects like 2017 OF201. The dwarf planet's 25,000-year orbit is a testament to the delicate balance of forces in the outer solar system, where the sun's gravitational pull weakens to a whisper, and even small perturbations can send objects on wildly eccentric paths. This dance isn't just about 2017 OF201, it's a choreography involving countless other TNOS, each influenced by the subtle tugs of nearby planets, distant stars, and perhaps even the hypothetical Planet 9. As of 2025, astronomers are using advanced N-body simulations to model these interactions, mapping out the gravitational ripples that could reveal the presence of a hidden giant. These simulations are like cosmic time machines, allowing us to rewind or fast forward the solar system's history to see how objects like 2017 OF201 came to be. The fact that this dwarf planet has remained stable for billions of years, despite its extreme orbit, suggests a solar system more complex and dynamic than we ever imagined, a place where gravity and time weave stories that span millennia. The discovery of 2017 OF201 isn't just a scientific milestone, it carries a profound philosophical weight. It forces us to confront our place in the universe, a speck of curiosity orbiting a modest star in a galaxy among billions. The search for Planet 9 and the study of distant objects like 2017 OF201 challenge us to grapple with questions beyond science. Why do we seek these distant worlds? What does it mean to find them? As of August 22nd, 2025, these questions are resonating in academic circles and public forums alike, sparking debates about humanity's role as explorers. Are we driven by a need to conquer the unknown, or is it a deeper yearning to connect with the cosmos? Each new discovery, like 2017 OF201, is a mirror reflecting our aspirations and limitations. It reminds us that the universe is not just a collection of objects, but a tapestry of stories, each one inviting us to ponder our existence and our legacy among the stars. The pursuit of 2017 OF201 and the Planet 9 hypothesis is a global endeavor uniting scientists, amateurs, and dreamers across borders. As of 2025, international collaborations are at an all-time high, with observatories in Chile, Hawaii, and Australia pooling resources to scan the southern and northern skies. The European Southern Observatory's Extremely Large Telescope, ELT, nearing completion, promises to push the boundaries of what we can see, potentially capturing fainter objects than ever before. Meanwhile, citizen science projects continue to thrive, with platforms like Zooniverse hosting global communities of volunteers who analyze data from telescopes worldwide. This collective effort transcends language and culture, driven by a shared passion for discovery. It's a reminder that the quest for knowledge is a universal language, one that binds us together as we look to the stars. Whether it's a researcher in Princeton, a student in Tokyo, or a retiree in London clicking through telescope images, we're all part of this grand adventure, chasing the same cosmic truths. Here's where this story gets personal. Since 2017, astronomers have opened the hunt for Planet 9 to the public through citizen science initiatives like the Zooniverse platform. Anyone with a computer and curiosity can comb through telescope images, searching for the telltale motion of a hidden planet. As of August 22nd, 2025, these projects are more active than ever, with new data from the Rubin Observatory's Legacy Survey of Space and Time, LSST, pouring in. The next great discovery could come from an amateur stargazer, clicking through images late at night, spotting a faint dot that changes everything. Will it be you? This isn't just about finding Planet 9, it's about rewriting our place in the cosmos. The discovery of 2017 OF 201 reminds us that our solar system is still full of surprises, a vast frontier where every new object is a clue to our origins. Whether Planet 9 exists or not, the search is pushing the boundaries of what we believe is possible. It's a reminder that the universe doesn't reveal its secrets easily, but with persistence, technology, and a dash of curiosity, we can uncover truths that reshape our understanding of the stars. So, what's next? The hunt for Planet 9 continues, with telescopes scanning the skies and simulations crunching numbers. But this journey isn't just for astronomers, it's for all of us. If this cosmic adventure has sparked your curiosity, dive into the mystery yourself. Join a citizen science project, explore the night sky, or simply keep asking questions. The universe is vast, but it's not out of reach. And while you're here, let's keep the conversation going. Drop a comment below with your thoughts on Planet 9, share this story with a friend, or hit that like button to spread the word. The cosmos is calling, and we're all part of the story. Let's keep exploring because the universe isn't done surprising us yet.